Like I was saying, you can learn how to program on any platform, but that doesn't mean that you can solve ALX questions. ALX is taking you through a very robust syllable, a robust structure of programming, because they want you to be able to acquire all the knowledge that a computer science student will get from first year of tertiary education to final year. So what we are doing in 1 year is what computer science students are doing in 4 years. If you are able to survive ALX, you can survive anything. You can work at Microsoft, you can work at Apple, you can work anywhere in the world. If you can survive this 1 year of ALX and learn and actually understand everything they are teaching us, you are good to go. You can work anywhere, you can get any job, you can pass any interview. And I'm speaking from experience. So what we're going to do is that what's happening is that you are learning programming concepts. You are not just becoming a coder, someone who can code, someone who understands C, someone who understands Python or any language. You are becoming an engineer. That is how come it's challenging the way it is. So you have to take your time, give it time, and master the concepts. So what I'm going to do is I'm going to crash the core concepts that you need, because we're already behind time. I'm going to crash the core concepts of what we've done so far from the beginning of C to pointers, arrays, and strings. Then we'll try use those concepts to try our hands on a few of the projects. Then we'll know what to do. Okay, I'm not going to worry myself about all these, because you can read um, from ChatGPT or from the internet or from Google. And these questions you are seeing over here are some of the learning objectives that I copied from the internet. These are some of the learning objectives that I copied from the internet that I made notes on. So like, who invented C, who is Dennis Ritchie, how do you use printf, and blah blah blah. All these you see over here are actually learning objectives. We're not going to worry ourselves about them, because this is information you don't really need to know how to program, but it's nice to know them. Okay, but the most important thing we need to know right now is that there are categories of programming languages. Okay, so currently what ALX is teaching us is C. C is one of the procedural languages. All right, so when we talk about programming languages, we're going to group them into two main blocks. Okay, there are the high level languages, and then there are the low level languages. Okay, now the low level language is a language that talks to the operating system. Usually these are binary languages. What is a binary language? A binary language is ones and zeros, ones and zeros, zeros and ones. All right, so your computer does not speak the language that you and I are speaking. Right now we are speaking English. Okay, but the computer does not speak English. The computer speaks zeros and ones, binary language. So that kind of machine language is what is known as a low-level programming language. And then there are also higher-level programming languages that are written in languages that you and I, the programmers, can understand. So such languages include Python, JavaScript, Java, etc. Several programming languages. Okay, so this is what you need to know for now. There are high-level programming languages, and then there are low-level programming languages. But the question is that, what is a programming language? Right now, I'm communicating with you guys. Okay, I'm talking to you guys right now, and I can switch my language, and I'll start speaking Ewe. I don't speak Ewe though. I speak Ga, I speak Chi, I speak English. But assuming you don't understand Ga, okay, and I suddenly switch and start speaking Ga, like to your thing, I'm speaking a language you don't understand. But if I want to communicate to you in a language you understand, I have to communicate to you with a unanimous language that you and I understand. Programming is simply you talking to your computer. So in order for you to talk to your computer, you need to speak a language your computer understands. And this is where programming languages come in. And there are several programming languages, just like there are several human languages. You see, I said, my Chi is not very good, but we can start speaking Chi right now, or we can start speaking Ga right now. We can switch to any language. So assuming I'm speaking English right now, let's say I'm speaking C, and I switch, I start speaking Chi, and ask you that, what you saying? Then maybe I'll switch, I'm speaking Python, another programming languages. So all the programming languages that have been invented and developed are languages, they are high level languages, okay? They are high level languages that allow you, the developer, the human, okay, you, the human, to be able to communicate with your computer. It's a very simple thing. Then let's say you write a C program. So I write C, blah, blah, blah. I write some program in here. That hello world or printf that I've written in here, the computer does not understand it. So it needs to be translated to machine code, which is made up of zeros and ones, binary language. And this translation process from a language that you, Henry, or you, Inshira, wrote in C, that English language or that programming language you have written in your code needs to be translated to binary code so that your computer can understand it. And that translation process is what is known as compiling. Okay, so you compile your code and then it is changed to binary code for the computer to understand. This basically is a foundation of any C program that you're going to write. If you understand this, like you have your leg in the door, you are ready to start working. This is the foundation of everything you're going to need. Then, one more thing you need to understand. In a computing structure, there is your hardware, which is your computer. So that's your mouse, your CPU, and everything, which is your hardware. Okay. Now, on top of the hardware, we have something called the kernel. Right? This is the kernel. Now, your kernel is like the central component of the operating system. So your kernel is like your operating system. And then any program that you are writing communicates with the kernel. But the kernel does not understand English language. It doesn't understand French. It doesn't understand any language. It only understands binary language, zeros and ones. You don't know what binary language is, you might want to read on it on Google or anywhere. Your kernel only understands binary language. So that is how come whatever programming language you write, whether it's a high level language or whatever programming language you write is translated from the language you wrote it in to a binary language. So this is the computing structure that we have in every programming. But over here, we have something called the shell. I believe in ALS, you guys are using that black interface. You type in commands and then you receive output back. That is what is known as the shell. So when you type your command in the shell, it now comes down into. I think someone is saying you should let them in. Henry, someone just put on the page that you should let them in. So check. Probably someone is trying to come in, so admit them in. Okay. So whenever you put commands in your shell, the shell passes the command to the kernel, and the kernel executes the command. Then you have your shell, the commands back in your shell. So let's say I type a command like ls in my shell, then it's going to list the files in my directory for me. That command that I typed in my shell, when it lists the file back, it lists it back in the interface of the shell, which is known as the terminal. These are foundations that you need to know. That is why I'm telling you these things. Okay. Now, when the terminal is like the screen of the shell. So that is what outputs your result to you when you put some commands in the shell. So let's say I type ls and the files in my directory are listed on my screen for me. That screen is what is called the terminal. This structure you are seeing is how computing works. All right. And the reason why I'm showing you this is because we are going to apply it in programming, in everything that we're going to do in C. So stay with me. All right. So now we have the foundation. We know how the computer is going to change human written code into compiled code that the computer understands. But the question is, how is the computer going to do it? You're writing C code, but then how is the computer going to translate or compile? The right word to use is compile that C code into machine code. There are softwares that have been developed by many senior programmers that you can use to compile your C code from the human written code to machine code. And one of those key softwares in the programming world is what is known as GCC. GCC. GCC is an acronym for GNU's Compiler Collection. GNU itself is an acronym. Okay, it means GNU's not Unix. It's like a recursive acronym. You don't need to understand what all these things mean to be able to program. But what I need you to understand right now is that GCC is a compiler. It changes the human written code to machine code. That hello world or that printf or that standard input and output you have written in your C file, the GCC is a compiler that will change it into zeros and ones. It's going to change it into a machine code. It's going to change it into a low-level programming. It's going to change it into a binary file so that the computer can read and understand and then execute the commands that you put in your file. That is all you need to know about GCC. It is what? A compiler. But then ALX has something interesting that they use to compile your code. They are called flags. I hope you are with me. Now I want to show you something. This is the C Hello World project that you did. That is the first project that you did in C. Now, if you look at this carefully, you're going to realize that GCC is what is used to compile your code. However, there are these several flags you see over here, which are added to the compilation so that they are like robust flags that ensure that every little error you make in your code, the compiler is going to catch it. You don't bring a white space, the compiler will catch it. You just make a small punctuation error, then the compiler is going to catch it. This is what makes ALX very difficult because they are adding all these flags to the compilation process. I'm going to demonstrate this to you. You're going to understand what it means in a moment. And then there's also what they call the Betty file. The Betty file is also a program. It's also another kind of program that your code is passed through to ensure that it conforms to a certain standard. So what you need to know currently is that your code is going to be compiled with GCC, and there are several flags that GCC is going to compile your flag with, your code with. There are several flags your code will be compiled with. And then also there's something called Betty that your code must align to in ALX. All right. So let's just go straight into my terminal, and then we're going to start trying to do a few things. The default terminal that ALX allows you to work with is VI. So I'm not going to work in anything. I'm going to work in VI. Then we are going to create a very simple C program. And with that, I'm going to explain a number of things to you. Then we move forward. So you guys already understand this, how to create a file. I'm going to create a file. And usually what I like to do is that I like to use names of people here to create the file. So let me go find a name. We have, let me use Felicia. Sorry. Okay, so I'm going to create a file. I'm going to call it Philly.c. Whenever you are creating a C file, the extension that you use is .c. So anytime you see a file with .c, it means it's a C file. If you see a file with .py, it's a Python file. If you see a file with .html, it means that it's an HTML file, hypertext markup language. If you see a file with CSS, it means that it's a cascading style sheet. You see a file with JS, it means it's a JavaScript file. So there are several extensions that you name a file. But when you're writing programs in C, your extension that you use is .c. And this is the reason why ALX asked you a question in one of the quizzes. I was going through it some time back, and I realized that it's one of the questions that was in the quizzes that were asked. So I think it's this one. What is a common extension for a C source file? And the answer is .c. So whenever you are creating a source file, what is a source file? It's a file that you put your C program in, your C commands. That is your source file. So the extension is .c. Right? So here am I. I've entered VI. If you don't know how to use VI, you can Google. There are several resources that can help you use VI. Very simple. So when you open VI, the first thing you want to do is to set the number so that you get a line numbers by it while you're in the command mode, and then you can also set the syntax so that you get a colored output. Okay. Now, to write a simple C program, you do something like this. Okay. Hash include. I know you guys are familiar with this, but I'm writing it because I want to explain a few things to you. So standard input output at H, syntax on. Good. So I can get a nice colored output. All right. Then from here, you're gonna do something like int main. Sometimes you're gonna say void, open curly braces. Then you're gonna say return 0. What do all these things mean? Like when you're writing C program, what do all these? Why do we do all these things? We're gonna do something like this. Okay. Now hear me out carefully. Hear me out carefully. Whenever you're writing a C program, this is the structure you're gonna abide by. Whether you go to heaven and come down. If this is looking cryptic to you, don't worry. We're gonna break it down. Whenever you're writing a C program, this is what you are always gonna do. However, you may not write these exact same things there, but the structure will always be like this. And there's a reason why. The structure will always be like this. What you see over here as the first line, line 1, it is known as a pre-processor directive. Okay, so let me comment out this file. So this is a pre-processor directive. What is a pre-processor directive? Hold on a minute. I'm going to come back to it. I'm going to tell you what it is. But before that, let me explain something to you called header files. I'm sure you have seen header files. What is a header file? What I put over here is known as a pre-processor directive. At the same time, it's also known as a header file. Now I'm going to go into the quiz. I'm going to show you one more thing. This question says that what is a common extension for a C header file? And the answer is .h. We realize that a C source code file has an extension .c, but a C header file has the extension .h. You guys have seen include main.h, include main.h, include main.h, include main.h, and you have just been typing include main.h, include main.h. Why are you including this main.h? That is what I'm trying to explain to you right now. Okay, so whenever you're writing a simple C program, the first thing that you're going to do is that you include your header file. But why must you include this header file? It is because it is a function. What is a function?
Yeah.
Great. So I'm going to write a program. I'm going to have a square, and I'm going to have, let's say, a triangle. So this is a C file that I'm creating. So this is my C file. This is a .c file. So whatever this file is, let's say it's Felicia, like the file we created. So this is Philly.c. This is a .c file. So I'm writing the program, and you realize that many times when you're writing the program, you bring something like printf, then you print something. Okay. This printf function, what is it? It's a function. Assuming I'm writing this program, I'm supposed to implement a shape. So over here, I'm supposed to draw a circle. So I'll come and take my time and draw a circle. I'm writing a program. I'm supposed to draw this shape, a square. I'll take my time and draw it. I'm supposed to draw this X. I'll take my time and draw it. Realize that I'm wasting time. So someone came up with an idea that why don't we create pre-processed functions? And then we are just going to name these functions so that when you want to use any of these functions, you just call their name. Then that function will do everything that has been pre-processed into it. So people were like, okay, fine. Now let's develop a standard library. Now hear me out well. We are about to get technical. I'm about to, if you lose me in the foundations and we climb up, you can ask questions though, don't worry. You can always ask questions. But we've been taking things easy. I don't want things to get too technical for you. So I'm taking it easy. But I need your attention here because I'm about to get technical. And this is what's going to determine what we are going to do next. So if you don't get this, you're going to miss me out. Hear me out well. People said that why don't we develop a standard library so that instead of when we are writing a program now, we have to come and draw these shapes on our own. Let's create them down and we're going to give them names so that when anyone needs to draw any of these shapes, they'll just call their name. So Leo says you call this one A, you call this one B, you call this one C, and call this one D. Okay? So when I'm writing my program, when I get to the point where I have to implement a circle, instead of now taking my time to draw a circle, I might even get it wrong. I might not even draw the shape well. So I'm just going to say A, and the C compiler understands that when I say A, I'm talking about a circle. Then I'm writing my program. I get to the point I have to implement a square, but I don't even know how to draw a square. I don't even know how to draw straight lines. I'm going to draw it, and the lines are going to end up twisted. So to make things easy for me, they said that okay, we have created a square for you, and we have named it B. So whatever you need to draw a square, don't worry about drawing it because you have very bad lines. The way you draw lines are very poor. So now just say B, and the compiler understands that when you say B, you're talking about a square. So all of these you are seeing over here are called functions. Okay. Now hear me out carefully. These functions that you are seeing are categorized. These functions that you are seeing are categorized. Okay? What do I mean by that? So, for instance, this A function that you see, there are sub functions within the A function that you see. So, inside A has its children. Okay? So, we are going to call the children of A A1, A2. Then B has its children. So, there's B1 in here, there's B2 in here, there's B3 in here. Then X has its children, there's X1. And D has its children, there's D1, D2. All right? Stay with me. Don't get confused. It's not complicated at all. So, everything that you are seeing over here, everything that you are seeing over here, which are called functions, which have been pre-written for you, they are called the standard library. Get it? So, I'm writing my program. I get to the point I have to draw an X shape. I don't have to worry. All I have to say is X. Or all I have to say is C, rather, because we call this C. And then the program, the compiler understands that when I say C, it's going to implement the X shape. With this basic understanding that you have, so we can come and say that, all right, there is a function that draws a circle, there's a function that draws a square, there's a function that draws an X. But I want to write a function that draws a shape that is not in a standard library. So now that there's no shape like that in the standard library, what do? I need to create my own function. So now I'm going to come up with a new function, which I'm going to add to the list of functions there are. And I'm going to, let's say I want to draw a new shape that doesn't even exist in the system. So let's say we want to draw, what shape should we draw? What shape should we draw? Anyone should suggest the shape that we should draw. I want somebody to talk. I'm going to mention names. Ishmael, you're here. Welcome. Ishmael, you're welcome. Can you hear me?
Thank you, engineer.
You're welcome.
Please, you can draw trapezium.
Please, I don't know what the trapezium is. Okay, fine. So we are going to
rhombus.
we are going to draw a new shape, which is a rhombus. Okay, so we're going to do like this. We'll do like this. We'll do like this, and we'll do like this. Okay. Then we are going to give this shape our own name. Okay. We're going to call it Ernest. Okay. So even though the standard library has functions that are pre-written for you, now you can create your own functions and name them anyhow that you want. These functions that you create on your own, they are called user-defined libraries. Now hear me out well. Don't get confused. These are your foundations. This is what will determine whether you understand what you're doing or not. The functions that have been written for you are called standard library functions. The functions you write on your own as a developer in C, they are called user-defined functions. User-defined functions. Okay. When you are writing a C program, you realize that when I wrote this program, I said include standard. This stdio.h means standard input and output. Okay. I said include standard input and output.h. What is that? This thing you are seeing is one of the standard libraries. What you see over here. This include standard input output.h you are seeing over here is a part of the standard libraries. And just like I explained to you, assuming this was the standard input output.h, so this is stdio, it has children in them. So inside the standard input output library function, there are several functions in it that you can call. And one of them is printf, which prints things to your output. So assuming I wanted to print something over here, I'm going to say that printf we can decide to print a text. We're gonna say hello, Shira. You get me? With, with, without including the standard input output.h, I couldn't have used this printf because this printf, sorry, this printf is a child of this function. And printf is not the only function in the standard input output.h. There are several of them. There is put, there is put car, there are several of them. I'm going to take you into my notes. I'm going to show you something. I hope this illustration that I've done makes some sense to you. Does it make sense to you? If it doesn't make sense, go ahead and ask questions. Does it make sense to you? I need some response.
It does. Yes, please.
Thank you.
Right. But I want to ask a question.
Sure, you can go ahead.
Yes, is it possible to write a C code
Mhm.
without including any function? That's the first question.
It's impossible. Okay. Okay.
And the second question, is it possible that even though certain functions are already standard, you can also create a function of your own, that's the user-defined function, by defining a function which will print out an output, even though there's already one.
Exactly. What you have said, as a matter of fact, what you have said is what ALX is making you do. All right. I want to show you something. The second question you asked is exactly what ALX is making you do, and that is what makes ALX difficult. I'm going to show you a few things. I'm looking for a number of functions that I put together, and then I'm going to header file. So where are my header file notes? Okay. This is GCC compilation. I don't think they are here. So let's go to functions. Let's see if I have my header file notes in there. Yeah, it should be here. Exactly, I have it here. Okay, I'm going to answer your question. All these are my study notes, all right? So whatever you're seeing here, these are my study notes. Great, great, great. This is what I'm looking for. Okay, so now the standard library functions. What a lot of people are familiar with standard inputs output.h, but there are several of them. There's string.h, there's math.h, there's standard library.h, there's type h. See, you can go on and on. There's no end to the standard libraries. There are a lot of them. You can go and read them on Google. You don't need to memorize them. You can't. So don't try to memorize them. But then, in answer to the question that you said, for instance, if I include the standard library, I have the freedom to use functions such as printf, scanf, getc, etc., etc. And all these functions have what they do. If I include a function like math.h, then I can use math functions such as square root, sine, cos, tan, power, various math functions. There are numerous functions you can use in math. If I include, let's say, something like standard library.h, I can use um, um, functions such as malloc, calloc, realoc. You're going to come to these things very soon. Okay, so these are standard library functions that have already been pre-processed and pre-defined for you. Now, ALX will give you a question in answer to the question you asked, and then they will tell you that this question that they are giving you know very well that you can use printf to do it, but they will tell you that don't use printf because they want you to go and define another function which does the same thing that printf is supposed to do. I'm telling you. And that is what makes life really difficult in ALX. Now, for instance, you know what? Let me minimize this a bit. Let's go to the functions project that you did. It's because you guys have done all these projects already. So I could have gone one step at a time, but this time around, I'm moving here and I'm moving there. I'm moving here and I'm moving there so that everything becomes one soup for you because you guys have already done all these. And I expect that you're familiar a little with them, even if you don't understand what you did. I'm trying to explain what you did to you. So I'm going to go into this functions and nested loop project and look at the requirements that you're given. ALX says that you are not allowed to use standard library. Who asked the question? Who asked the question?
Yeah, I do.
I mean, who? I didn't get a name because I can't see. Yeah, because when you're talking, I'm only seeing my screen, so I don't see the Google interface.
Oh,
okay. Yeah, I only see my screen. So ALX is telling you that you are not allowed to use the standard library. Remember, we know what standard libraries are now. And then any use of functions like printf, push, etc. is forbidden. Yet, look at one of the questions that they're going to ask in this. They're going to ask you to print something. But in order to be able to answer that question, you needed to use a function like printf to be able to print it out. But now that they are telling you that you cannot use printf, they've left you hanging. You don't even know what to do anymore. So now it is up to you to create your own function that does what printf does. So what the standard library has done for you, ALX is telling you that write it from scratch. Does it make sense to you? So you can actually write a function that has already been pre-written for you. And the reason why they are doing that is that they are training you. So One of the functions that can do what printf does is put car. So they are telling you that you are allowed to use put car. So ALX is telling you that you are allowed to use put car. You don't have to push your putcar.c. They will use their own putcar.c. And then they have another set of file called main.c. All right. Then they tell you that the prototypes of all your functions and prototype of the function putcar should be included in your header file called main.h. What do all these things mean? I'm going to help you. This is what ALX does. This is the structure of ALX projects. Okay. Now, when you are writing a C program, the first thing you do is that you are going to include your what? Header file. No doubt about that. You definitely need to include your header file. Then the header file has what extension? .h. So whatever file you include is going to have a .h extension. There's no doubt about that. Now, when you are done, you come and include your int main function. You are going to understand what this means. I'm going to explain to you. Then you close your int main function, and then whatever else will come. Now listen to this carefully. ALX is telling you that you cannot use a standard library, which means that whatever function you're going to use, you have to create it on your own. That is where the main.h file comes in. So if ALX was allowing you to use your own, to use the standard libraries, there wouldn't have been any need to create the main.h files. But they are forbidding you from using the standard library. So you cannot come here and say include standard input output.h. You are forbidden. They don't want you to use it. So what they make you.
Sorry, please, can I say something?
Sure.
Henry, please, can you admit George? He's trying to join, but he's not being
Yeah, I think I'm seeing it on the page over here.
Oh, okay. So let me check and then unmute him.
He's checking constantly on your phone because people will try to join.
That's true.
Okay, sure.
That's why I didn't want to set up the meeting because I have to be posting to admit people in. That's why I made someone else do it. Okay. So ALX is saying that you cannot include standard libraries. So now you have to go and create your own file. Now this file is known as main.h. Now I'm about to say another thing and I need you to hear me out carefully. I'm going to, okay, before I open it, let me explain it to you so that you understand why it is that way. Now this C program that I wrote, if you look at it carefully, this is a syntax, whether you like it or not. When you are including something, the first thing you have to do is to include the hash sign. Okay. So when you are including your header files, the syntax, memorize it. As for this one, just let it be in your head. Just memorize it. The syntax is the hash sign, then you bring the include. However, what you include depends on whether you are going to use this less than, greater than sign or quotation marks. Now hear me out well. When you include a standard library, you will use less than, greater than quotation marks. But when you include your own user-defined library, it's going to be in quotation marks. When you include a standard library, less than, greater than, the standard input output.h is a standard library, so it's in less than, greater than. But if we include our own file, main.h, then it means that we cannot use the less than, greater than. We have to change it to quotation marks. So this is the reason why you do this. So main.h. So if you go and look at all the files and the assignment that you copied and pasted, which you included main.h, you're going to realize that the main.h is in quotation marks, not less than and greater than sign. When you're including a standard library, it is in less than and greater than sign. When we are done with this class, go back and go and check the codes that you copied and pasted. You realize that when you included the main.h, they were in quotation marks. That understanding is settled. We are moving to something else. So initially when I started, I wrote a basic structure of how C programs are written. But right now, you're realizing that I'm beginning to change the thing. Initially, it was a standard library. Now, I've changed it to a user-defined library. So what I need to do now is that I need to exit my VI over here. I need to create a new file called what? Main.h. Because I'm about to define my own header file now. ALX says I shouldn't use the standard library. They want me to create one of my own. So I need to go and create that. So I'm going to create a file, main.h. The VI you are seeing over there simply is an editor. It helps you create files. It helps you edit files. We could have used some VS Code, but ALX says again that you are only allowed to use VI, Vim, and Emacs. So we can't even, they are just making life hard for you. They are doing that because they are training you, like I told you. So you cannot use VS Code or any other editor in the real world, which makes life easy. So we're going to use VI. And to create a file in VI, you VI and then the name of the file. You already know that. So I'll VI'd, and then I'm going to set my number so that I have my line numbers in there. Whenever you open VI, the first command you want to enter is colon set number so that you can have line numbers. You can have line numbers when you're coding because VI won't give you the line numbers automatically. And then maybe you also want to bring the syntax on so that you have a colored output. I think in your sandbox, it's already colored, so you don't have to worry about the color. But if you want the line numbers, you do set number, and the line numbers are gonna pop up. Now, inside my main.h file, what goes into my main.h file? ALX tells you that the prototypes, listen to this carefully, the prototypes of all your functions and the prototype of the function putCar should be included in your header file main.h. So this means that you simply have to understand what is a function. What is a function? How do you declare a function? And then you also need to understand what is a function prototype, because it is a function prototype that you carry and then you go and put it inside your main.h file. So this simply means that you need to know what a function is. Then you also need to know what a prototype of a function is. We are taking it one step at a time. I just have about 30 minutes more to go. By the time I'm through, you understand why you did what you did in the if else project, the functions project. I'm not going to touch on pointers today, probably on Friday. But I want to crash everything as much as possible so that everything you have done all the way to functions, you understand everything, why you did everything that you did. So I'll be going back and forth. If you don't understand anything yet, calm down. You're going to get it by the time we're done. Okay? So, in summary, this is all that I've said so far. When you are writing a C program, the first thing you do is to include what? Your header file. My pencil is trying to misbehave. You include your header file. In the header file are standard libraries, either standard libraries or user-defined libraries, any of them. But ALX now comes to tell you that, hey, we want to make your life difficult. We want to train you to become a very hard and strong programmer. So don't rely on any standard library. Create your own library. You're not allowed to use printf. You're not allowed to use put. Create your own function, but you're allowed to use putCar. Now, if you look into these requirements carefully, ALX tells you that you are allowed to use putCar. So this means that you have to understand what the putCar function is. If I were in your shoes, all I'll do is that I'll just go to ChatGPT. I'll go and type, what does putCar do? What is the putCar function? That is how you learn. That is how you learn. The putCar function is simply a function that prints a character. The putCar function prints a character. So ALX tells you that you're allowed to use putCar. So now we need to define our main.h over here, and we are going to create our main.h file. Okay, but what goes into the main.h file? Remember that if we had used standard input output.h, then we can use printf. Right now, we are about to create our own function called putCar, which will help us to do what printf was supposed to do. So we're going to create putCar, and putCar is going to print a character, whatever we want it to print. This means that we now have to go and create another file, which will be the putCar function. Do you get it? All this is happening because we have been forbidden from using the standard library. If not, life would have been really easy, would have gone. But right now, everything we are trying to do now is because of the requirements of ALX. So you now need to go back. This is your main.h file. I've not put anything in it yet because we don't know what's going to go into it yet. They say that our prototypes will come into main.h, but we don't know what prototypes are yet. So let's exit out of here. I'm going to ls. Let's see the files that we have so far. Oh, I was working in my main. I was working in my home. So I didn't create any directory to work in. So I have so many things over here. No problem. Let me open my graphic user interface, and then let me clear my screen. Let me make a directory. Um, I'm gonna call it uh, I'm gonna call it George. I see a new person here called George. I'm gonna call my directory George. Okay. Then I'm gonna cd into George. So I'm inside George now. I'm gonna work inside George. So everything I've done is not gonna come into George. Remember that we created a file called main.h. So I'm just repeating everything we've already done. We also created another file called what was the name of the file? Felicia.c. So fili.c. That's gonna be our main source file that we work with. Then inside this file, we included our standard libraries. So we say include. Now, no more standard libraries, so we include main.h. And I told you that when you do a user-defined function, it is in quotation marks because it's user-defined. Then int main, we're gonna understand what this means in a bit. Then we open a code block. Then the function returns 0. I'm gonna teach you why it returns 0. Okay, great. So this is what we've done so far. So I'm gonna get out of here. And what else did we create? So, like I was saying, we now need to go and create our putCar function. So if you look into the requirements of ALX, it says that you're allowed to use putCar. So you need to create a file called underscore putcar.c. And this putcar.c is what is going to do what the function printf was supposed to do if you had used a standard library. So you now come and you're going to create a file called putcar.c. Simple. So what is supposed to go into the putcar.c? It is at this point that you need to understand what functions are. What are functions? And I already explained to you in my notes that functions are things which make your life easy. So you're writing a program, you're supposed to implement a circle, but the circle has been called A. So instead of taking your time to draw the circle, you just say A. And then everybody knows that you're talking about a circle. Or you're writing a program, you're supposed to draw a square, you call it B. Instead of drawing the square, you just say B. And everybody, the compiler knows that you are talking about the square. But the question is, how do you define a function? How do you write functions? The way to write a function is to bring, number one, the data type, meaning that we now need to go and understand what data types are. You bring the data type, then you bring the name of the function. That one you can give it any name, but there are naming conventions, which means that we now have to come and talk about how to name functions. Then you bring your parameters, which means that we now have to come and understand what parameters are. Then now you bring your code, which your function is supposed to execute in this block. All this is what is bringing the plenty things. So I'm going to open a new sketchboard. Then we're going to understand what is going on here. Okay? Stay with me. Don't get confused at all. I'm going to put everything together. So like a lot is happening, but by the time we are through, everything will come together into one big picture. All right? So I'm going to open a new sketchboard. We are supposed to go and create our own putcar function, which will do what printf was supposed to have done for us easily. And all this is because ALS says you can't use standard libraries. So now we are using user-defined libraries. And in a bid to do that, we now have to go and create a function called putcar and come and use it. But to be able to create the putcar, we need to know how to create functions. So what are functions? Then I told you that the way to write a function is to first bring the data type, then you bring the name of the function, then you bring the parameters of the function, then you bring the code of the function, what the function is supposed to do. So now, if we are supposed to bring the data type of the function, we need to understand what data types are. The question now becomes, what is a data type? So we are going back to the second project that you did, if else and nested loops. Everything, I'm going to put everything together. Stay with me, and I need your rapt attention. Open your mind and stay with me. So I'm going to use like a minute to brush on data types. Then we'll now come and define our function. So let me create a square over here, which we'll use to talk about data types. So we are talking about data types here because in defining the function, you need to bring your data type. We don't know what data types are. We are talking about data types. There are two main data types in C programming language. There are two main. Actually, there are several of them, but they can be categorized under two main data types. The first one is the integer data types. And the second one is the floating point numbers. Floating point numbers. The integer data types consist of int, which stands for an integer. What is an integer? 1, 2, 3, 4, 5. This is simple mathematics. Core maths. Those of you who had A in core maths. An integer is simple. Whole numbers. Thank you. Then, as part of the integer data types, there is also what is known as the char. C-H-A-R. The char. It simply stands for character. So this character data types is what will make you print A, B, C, D, E, F, G, H. Integer prints what? Whole numbers. Character prints what? A, B, C, D. You cannot just print small cases with characters. You cannot also print upper cases, A, B, C, D. So you can print upper cases with characters. You cannot just print small cases and upper cases with characters. You can also print symbols with characters. So plus, asterisk, hash, whatever symbol you want to print, the character data type will help you print it. So the character data type falls under the broad category of the integer data types, even though it prints characters. Are you with me? You're going to need this. Listen to me. And the character data type also prints symbols. So if you want to print a symbol like at, the character data type also print it. However, when you want to print a character data type, you have to put it in single quotes. So I want to print small a, I put it in single quotes. I want to print at gmail.com, I put it in single quotes. If you don't put it in single quotes, your code will give you an error. Okay, so we understand integer, whole numbers, character, letters, and symbols. Then under the integer data types, you could either have unsigned integers or signed integers. Stay with me, don't get confused. Whenever you say an integer data type is unsigned, it means only positive values. So as part of the integer data types, I can come and say unsigned. What have I just spelled? Unsigned int. It means I'm only referring to positive values. Okay. So let's put the integer data types aside. Then apart from that, we also have the floating point numbers. And those data types print decimals. So I want to print 1.2. I use a float. Or I can use something called a double. All these print decimals. A double prints to, I think, 5 or 6 decimal places. And a float prints to, I think, 4 decimal places. I'm not too sure. You can go and check these things out. I'm not the one to be teaching you these things. I'm just trying to summarize everything for you. Okay, so when we talk about data types, this is what we are referring to. There are several data types. Integer, We have the int, we have the car, we have the positive, and we have the negatives. Everything is int, okay? Then we have the floating point numbers, which is a float and a double. Wonderful. Now hear me out well here too. Whenever you want to use the standard library to print a data type, use something called format specifiers. Say it after me, format specifiers. Okay? So this is where format specifiers come in. Can you guys hear me? I was just receiving a call. Usually makes the network cut. Hello?
Yeah, we can hear you.
Okay, great. Because I was just receiving a call. Usually makes the network go away. Now,
Yeah, we lost you a little.
yes, because a call was coming through. All right. Whenever you are going to print, use a standard library, printf, to print a data type, you need to do so with something called a format specifier. So it's the same thing we are doing, just that there are several convolutions to it. There are several variations, like several things coming up. Okay. So if you want to print, let's say I want to print f, and I want to print a number. Let's say I want to print 1. I cannot just come and say print f1. No, it's not going to work. I have to use something called a format specifier. And the syntax for that is %d. Then you bring the name of the variable, which means that we have to go and understand what variables are. And Sando, and Sando, and Sada. It keeps going on and on. It keeps going on and on. But it's one and the same thing. It keeps going on and on. But it's one and the same thing. And Sando, let me not take you into variables yet. I'm sure you have a fair idea of what variables are. We'll talk about them. For now, don't let it jam in your head. Just have a general idea that whenever I want to print data types, I have to do so with format something called format specifiers. Then there are several format specifiers for each data type. The character has its own format specifier, the float has its own format specifier, the double. Just have that general idea for now. Let's not get too technical. Let's just leave it there for now. Okay. So now we have understood that there's something called data types. Okay. Now, so we are about to declare a function. Okay. And the reason why we are going through all this stress is because we want to define a function called putCar, so that we'll use a putCar to print out something in a project. Okay, so the putCar, the putCar function, what it does is that it prints a character. So if you are going to define a putCar function, then that means that we have to use a character. Okay, but then I'm just realizing that I have to teach you something called ASCII. Okay, I feel like it's becoming too much. I'm putting too much together in one lecture, so I want to take my time and confuse. So you guys are already familiar.
No, I think don't change
No,
my mind.
it's okay. The way you are going,
It's good he's taking us through everything.
all that you are doing is perfect. Take us through it. It's really good. You are on the right path and you are really enjoying the lecture. And I'm just like, once you mention it, just we are kind of familiar
Okay, so
with them, but we don't really understand some of them. So just keep on. Right?
okay,
We are not really
when I'm done, you can definitely ask questions. So don't worry. So let me just go on. You can ask questions. Now hear me out carefully here. That's because things are about to get complicated. Hear me out here. Okay, I'm about to talk about ASCI. It's the short form for American Standard Code for Information Interchange. ASCII for short. Every character has a pair, a number pair in Universal Standard. The reason is that the computer that you are typing on does not understand English language. It only speaks binary language. So if you come and write A in the computer, that computer doesn't know what you're saying. The computer is going to translate this A into binary code. Yeah, are you with me? So this A in binary code is going to be some zeros and ones. Then the computer understands that, okay, what you type, the A that you pointed on the keyboard, the computer thinks in binary code. So the computer will convert the A into zeros and ones and know that it is A that you are typing before you see A on your Word document that you're trying to type. Now, I need your attention here. That number pair, there is an international standard to all numbers in existence, all characters in existence, all symbols in existence have a number pair for the sake of the computer's interpretation. China, America, um, Africa, every continent in existence have come to an agreement in computing that let us all agree to this standard in computer interpretation. So the whole world have come together and we have all agreed that, okay, So when we say the letter capital A is supposed to be paired to a certain binary number, when we say capital B is supposed to be paired to a certain binary number, when we say small a is supposed to be paired to a certain binary number, the whole world has agreed on the standards. And that is what is known as American Standard Code for Information Interchange, because the Americans, they got to know. They are the ones who come and say that we are the one who brought it, so name it after us. So even though it's called American Standard, it's actually a world standard. All right, if that is understood. So the character A in AXI is paired to the number 65. And I'm going to go into my um, resources. I'm going to leave this link in the chat box. So just copy it. Just copy it, and then you can save it somewhere. It is the ASCII table. So you can see that, let me explain, break something down here for you. You can see that all these, watch here, all these are numbers, decimal numbers, the first column. Then the bin you see over here, they are binary numbers, okay? Now, then you're going to see a symbol over here, okay? So, get rid of this. Wonderful. So, if you see the exclamation sign, it is paired to the binary number 001000, blah, 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 blah. So, this exclamation sign you see, when you type exclamation on your computer doesn't see exclamation. What it sees is this binary number. It interprets in its mind, in the computer's mind, this is the number you have typed. You are the one who thinks it's an exclamation sign, but it is not. To the computer, it's a binary number. I hope you're with me. Then that binary number has a corresponding decimal number, and that corresponding decimal number is 33. So I'm going to leave this link in the description, in the chat box, so that you can copy it and save it somewhere. Okay. Now, so you're seeing all these symbols over here. Now let's go and see if we can see characters. Like I told you, this is the character A, and it is paired to this binary number. If you understand binary, then you can tell that when you convert this to decimal, you're going to get the number 65. It's very simple, straight to the point. Don't go there, come back. Wonderful. The character capital B is paired to this binary number. When you convert this binary number to decimal, you're going to get the number 66. So all the characters and the symbols that you see over here have their corresponding binary numbers, and those binary numbers have their corresponding decimal numbers. So in the American Standard for Code for Information Interchange, every character has a corresponding number. And the reason why I'm explaining this to you is because of the putcar function. Okay, you have to understand this because of the putcar function, so that you understand that when you type a character, in your computer is not seeing a character; it is actually seeing a number. Hmm? So numbers are actually the same as characters in a computer's mind. So then the question is that how would a computer be able to differentiate between this A and the number 65 itself? There's no difference. To the computer, A is the same as 65. However, if you want to type in the character A for the computer to recognize that I'm not referring to the number 65, I am referring to the character A, you have to put it in single quotes. That is why Putzka works the way it does. Okay, so in AXI, when you're about to declare a character data type, you must always put it in single quotes, or else the computer will interpret it as a number and not a character. One of the projects that you answered, there's actually this question in there, the ASCII code, one of the functions project. In our subsequent meetings, I'm going to take the questions one after the other, and I'm going to explain to you why the questions were answered the way they were, based on these principles that I'm explaining to you. So now let's forget about all that ASCII and blah blah blah, and let's now come and declare our data type. To declare an ASCII, the putcar data type, use an integer data type. To declare the putcar function, use an integer data type. I'm going to tell you why. Because it's supposed to return an integer. I'll explain that to you. Then you bring the name of the function. You can name it anything. But this time around, we are declaring a putcar function, and that is why we are calling it putcar. So to declare a function, I told you bring the data type, then the name of the function. So this is our data type, this is the name of our function. Then you bring something called parameters. The parameters are the details the function is supposed to take. So assuming I want to add x plus y. This x plus y you see over here is what is known as the parameters. Now, if I feed in figures and I say that x is 1 and y is 2, then this 1 and 2 you see over here are called arguments. Arguments. So when you are defining a function, you bring in parameters. The parameters are like placeholders which are going to take values later on. Okay? So when declaring a function, you bring parameters in parentheses. So now the parameters for the putcar function, you bring the data type and then the name of the parameter. I open my code block. So this is a basic way of defining a function. You bring the data type, You bring the name of the function, then you bring the parameter. The parameter comes with its own data type and then the name. So you can name the parameter anything you want. So you bring the data type and the name of the parameter. And this you see over here is what is referred to as a function prototype. So let's go into our ALX project on functions and see. So you realize that for the tags that they gave you, they said that this is the prototype. And if you look at it carefully, this is a data type, it's void. Which means that anytime there is no data type, the function is not returning any data type, it's empty, the word used for it is void. It means that there is no data type. It's not returning anything, so forget about it. Then this is the name of the function. Then this is the parameter. It means that there's no parameter, there's no input. Then let's go to the next task and let's look at the prototype. You can see that this is the data type. This is the name of the function, and this is the parameter. The same principle it follows. For this one, this is a data type, it's an integer. Then this is the name of the function. Then this is the parameter. The parameter is also an integer, so it's called C. Then let's check one more so that you have an idea. This is a data type. This is the name of the function. This is the parameter. This is what is known as a function prototype. So they are telling you that all your function prototypes, you should copy them and go and put them in a file called main.h. And there's a reason why. That's because when the compiler is compiling, it will go into the main.h file and go and check all the function prototypes, and then to realize that, oh, actually there are this number of functions in this code. So when it is now compiling the rest of the code, it already knows that there are function prototypes, so it is expecting the real functions. So the function can also have several prototypes. For instance, if you look at this one, let's look for one with more than one prototype. I mean, more than one parameter. Let's look for one with more than one parameter. So if you look at this prototype, the data type is integer, then the name of the function is add, then the parameters are 2. So if you want to write a function with multiple parameters, then you write the data type and then the name of the parameter, then the data type, the name of the parameter. So this is a function prototype with 2 parameters, and you separate the parameters with a comma. Very simple and straight to the point. Okay, so
the function prototypes
Mhm.
are not standard functions. They are just functions that ALX wants us to create functions by ourselves.
Exactly.
ALX has given us functions how to name those functions that we are creating by ourselves.
Perfect.
And those are the prototypes.
You're done.
All of them were made of it.
You're done. That's the structure of ALX programming. That is the structure. So they are not allowed, even though they are now saying that don't use standard libraries, create your own function. Then they have come back again and they are telling you that name it this way. They are telling you that this is how it should be.
Please, can you repeat what you said? What you just said?
They are saying that you cannot use standard libraries. And yet they have the same ALX, they have come back and then they are telling you that name the function you are supposed to create on your own. Name it this way. Don't give it any random name. Does it make sense? So
Yes, it does.
So in a bid to create the putcar function, we bring the putcar data type, the name of the function putcar, then we bring the parameter. Then now inside the curly braces, that is where you bring the code that the function is supposed to execute. So now the question is that how do I create my own putcar function? I don't know how to create a putcar function. I'm just going to go to ChatGPT and then I'm going to type into ChatGPT, how do I create my own putcar function? ChatGPT is going to bring it out and explain everything to you. Don't think, don't struggle. You're not going to memorize this when you're working in a firm. In a firm I'm currently working as a software engineer, I wanted to say 99%, but no. 85% of the things I do, ChatGPT, Google, YouTube. Stop trying to know everything. You must not just see what you must do is to understand the concepts, understand the principles. When it comes to the implementation of the code itself, you will always have Google, you will always have ChatGPT, you will always have YouTube. All you have to do for now, just have a general idea of the concept. This is how it works. Then when it comes to the details and the minutiae, then you research. Your life as a software engineer will be a life of daily research to be able to do the things you have to do. Okay. So if I'm in your shoe, I'm supposed to create a putcar function. I don't know how to do it. I just go to ChatGPT. ChatGPT is going to tell me, do it this way. And I implement it. But then, for some reason, I've done it so many times, so I already know how to create a putcar function. Now, to create a putcar function, you use a Unix standard library. This one is not just part of the standard library. It's a low-level function. It is known as the Unix standard. So you create a Unix standard function. It is a function write. And then you're going to tell it to return 1. The reason why it's supposed to return 1 is because it's returning a character. Then now you bring the name of the variable that the function is supposed to hold.
Sorry, can you please repeat that part again? I didn't get it.
With a putcar.
Yes.
Okay.
You the right.
So before you write a putcar function, you have to include something called a Unix standard. Let me just make it simple for you. Let's open. I want you to see the putcar function. So let's go to one of my projects. Okay. So I'm taking you into my GitHub account. Let me take you to my repositories. Okay, let's go to ALX low level. All these are projects I'm actually working on. Where's ALX low level? Where's low level? Yeah, we have low level here. Then the Hello World project is this one. You guys are currently doing what's pointers or something. You have a long way to go, I'm telling you. Okay, so let me just go into, let's say, functions. Okay, and then this is putcar.c. Wonderful. This is what I'm trying to explain to you. No, this is not the one I'm looking for. I'm looking for dot underscore putcar.c, the function. Wonderful. So I'm gonna maximize it so you see what's going on here. Now, listen to this carefully. We are supposed to create our own putcar function because ALX is not allowing us to use printf. But before you can create a putcar function, you need to include something called the Unix standard. This thing you see over here, UNISTD, is simply the short form of the Unix standard, UNIX standard. The Unix standard is a low level function that allows you to create functions that output text to you, things to the standard output. Okay. And the reason why we need this Unix standard library is because they are saying that we shouldn't use standard libraries, but it's a kind of standard library. So if you look at it carefully, you realize that the Unix standard is in greater than and less than sign. And then the main.h is in quotation signs because we created a main.h on our own. But as for the Unix standard, it's already in the C compiler. So we are not going to, it's not our own file we are creating. We are importing or including that file because we need to use this function called write. You see over here, this write function. And then this write function you're seeing over here is what will allow you to create the function called putcar. Now look at this carefully. You're going to realize that this is the data type of the putcar function. This is the name of the putcar function, putcar. And this is the parameter of the putcar function. Very simple. Very simple. And then look at the curly braces over here. It means that the block of code of the function goes into the curly braces. This function is supposed to return write one. This one you see over here means the standard output. It's too confusing, so don't worry. Just accept it. In the subsequent meetings, I'll break it down further. This ampersand C you see over here is like a variable which holds the name of any file. And this one you see over here represents the byte, the number of byte that you are supposed to allocate for the putcar function. But the putcar function only prints one character, so you only allocate 1 byte. Let me show you something. In your first project, Hello World, in your first project, Hello World. So I'm going to go into the Hello World project. Then one of the questions said that you should print a string, but you were not allowed to use printf. So let's see. This one says that. So let's see. I think it's this one. This one says you can use printf. So you can just use printf and then print it out. Great. Wonderful. So with this particular task, it says that write a C program that prints exactly. Programming is like building blah, 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 followed by a new line. It says that use the function puts. You're not allowed to use printf. Now I don't want to use the function puts. Let's look for the one that said that use putcar. It's because I want to show you something about the putcar function. This one says that you are not allowed to use any function listing blah 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 or man. I think it's this one. So that's number 8, project 101 code C. So let me go into my GitHub and open that. So that's Hello World 101. This is functions. So let's go into Hello World. The advanced is one of the advanced tasks. And look at how it was solved. This is what I'm trying to explain to you. So that task that you want to go and copy and paste, I want to explain to you why you answered it the way you did. Okay. It says that write a C program that prints exactly and that piece of art, blah, 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 all this, whatever it is, followed by a new line to the standard error. Listen, to the standard error, not to the standard output. You are not allowed to use any functions listed in the blah, blah, blah printf. So they are saying that don't use standard libraries. It's as simple as that. Your program should return 1. Your program should compile without any warnings. That's when you use GCC. You already understand the compilation process. In our next meeting, I'm going to tell you what all these gray boxes mean. Whenever you see a project, you're going to see that it comes with a certain gray box. They're trying to show you something. We don't have the time today, but in the subsequent projects, I'll explain to you why they bring that gray box and what it does. Okay? So let's try and answer this question. If you look at the solution to the answer, they used the function write. That's what I'm trying to explain to you right now with the putcar function. Then they brought 1 over here. This one is what the function is going to return. Then this is the string that the function is supposed to print. It's like a placeholder. Now you can see a certain number over here, 59. What is this 59 standing for? Now you want to take your time. I don't have the time for that. When you count all these characters, 1, 2, 3, 4, 5, 6, everything is going to add up to 59. All the string that you see over here is going to add up to 59. So that is why you see 59 over here. It's allocating 59 bytes because each character corresponds to 1 byte. That is why in the function that we are trying to create in our putcar, you saw that it was 1. That with that one, this one was 1, and this one was 1, because it was going to print just one single character. But because this one is printing all this, we needed to assign 59 bytes to it so that it will be able to print all this character. This one has to do with memory allocation. ALS structure is so I don't want to use a bad word, but it's not beginner friendly, because this thing that they are asking you to do in the very first project is like an advanced concept. Yeah, I don't understand why they are adding it to the very first project, which is Hello World. It doesn't make any sense to me. But actually, if you understand it, it's a very simple thing that is going on here. They are using the write function, and to use the write function, you need to import the Unix standard. So anytime you see write, you're also going to see UNI standard.h. It's a header file that allows you to use the write function. Very simple and straight to the point. So what I was trying to explain to you with the putcar function in the functions project was that with that one, putcar is going to print just one character. So they assigned just 1 byte to it. Very simple and straight to the point. So I'm going to go back to my putcar.c, and you look at what I mean by that. So you see that it returns 1 because it's going to print just one character, and then we are assigned 1 byte to it because 1 byte corresponds to 1 character. It's as simple as that. So this is how you create your putcar function. Ask Google, ask ChatGPT, it will tell you how to do it. Now, after you have created your putcar function, then you are going to put the prototype of that putcar function in main.h. So if you look into your main.h file, you're going to see that it has all the prototypes of the functions, including putcar. So all the prototypes that I showed you in the file, they are all over here. All you do is just copy and paste, come and copy the prototype, come and paste them in the main.h. And this you see over here, I'm going to explain it later. It is called an inclusion guard. I don't want to go into it right now. Then you can see that the putcar function that we created in the putcar.c file, we have brought the putcar prototype and we've added it to the main.h file. So you see the data type, you see the name of the function, and you see the parameter. So all your prototypes come into the main.h file. So now that we have created our own putcar.c file, now we can go into all the tasks that they are asking. And then we are going to use that putcar function just like the way we would have used the printf if you were using the standard library. It sounds a lot, but take your time. It's really not complicated at all. It's actually really straight to the point. Today, if everything has come compounded to you, don't worry. It's because we are already behind, and I'm trying as much as possible to catch up to the present project by Saturday or latest by next week, so that we will be at par with the projects that ALX is releasing. That is why I was trying to put everything together. But if you have not understood everything I've said, this is the summary of it all. Okay? I'm going to put everything I've said together. Whatever.
Please, I want to ask with the parameter.
Okay.
Can you just use any parameter?
You can't just use any parameter. Let's say I'm writing a function that adds 2 numbers. Okay? So now let's define variables. So let's define a variable called a, or rather let's call it number 1, so that it makes sense to you. Number 1. So when you define a variable, the way to define a variable is to bring the data type and the name of the variable. I hope you guys know that. Very simple and straight to the point. Then we are going to define another variable. We'll call it number 2. And the reason why I'm using int is because I'm going to be requiring integer values. Assuming I wanted decimals, I would have used what? Float or double. Very simple. So let me comment it. So these are variable declarations. Very simple. Okay. Then now, I'm going to create a function that adds 2 numbers. Then when I add those 2 numbers, what will the solution be? What will the result be? It's also going to be an integer. So let's say I'm going to add 4 plus 2. The answer will be 6. So the answer, what the function is supposed to return, is the return type of the function. So that is the data type of the function. Remember I told you that when you are defining the function, you bring the data type, the name of the function, and the parameters. Okay. So what the function is supposed to return is the data type of the function. So I'm expecting that the function I'm about to create, which will add 2 numbers, should return an integer. So what data type will I use? Integer. Simple. Then the function I'm defining right now is supposed to add 2 numbers. So what will I call it? Make sure that the name of your functions are descriptive. So I'm going to call the function add number or add numbers. Okay. When you are naming variables and functions, you can either use the camel case. So I can say add, the first word has a small letter, and then the second word can be a capital, starts with a capital letter. So this is a valid name of naming variables and functions. Or I can say add underscore numbers. This is also another valid way. Or I can use add one. You can use letters and a number, a very valid way of naming variables. Or you can also use yeah, these are the basic ways. Just make sure that never separate your variables and function names with spaces. So you can't say add number with a space. This is wrong. And don't start the name of your functions and variables with numbers. So I can't say one number. This is wrong. So stick to these in naming your variables and functions. I'll finish talking about variables and functions just over here. So that's all of it. So
you've not assigned any values to those numbers. So why are you calling them variables?
no, over here I'm
You can call them variables.
I'm just teaching you how to name variables over here. Okay. I was just teaching you how do you name your
Okay,
variables.
Question is, why is it called variable?
It's called
The understanding of a variable. Normally you assign something before you declare.
the reason why variables are variable is because they are variable. They change. When we say something is a variable, it means that it's varied. It can always change. So I don't want to drift. So I can define a variable. I can say int number. Okay, let me define a variable and call it number. And I'll assign a variable a value 3 to it. Okay. I can come back later and say that number is equal to 4. The same number variable that I've defined, I've come to change the value. And now when I print this value, 3 is not going to come. 4 is going to come out. That's why they're called variables. Basically, it's as simple as that. So you can actually define a variable without assigning a value to it. Okay. You must not always assign a value to a variable when you define it. You can define a variable without assigning any value yet. So in this case, all that's going to be done is that memory space will be allocated to it, and the memory space is waiting for you to supply a value. Okay, so that's what's going on here. Now I'm about to define the function. I bring the data type of the function. The function I'm defining is supposed to add numbers. Then I'll bring the parameters. Now the one who asked the question about the parameters, here you go. So when I'm defining my parameters, I need to bring the data type of those parameters. The parameters is what the input value of the functions are going to be or is going to be, whether it's a single parameter, a double parameter. But here in this case, we are going to add two numbers. So I definitely need two parameters. So integer, and I'm going to call the first parameter num1. I'm going to say another parameter, which is also an integer, num2. Then I close my parentheses. Then now I come and open a curly brace and now define what the function is supposed to do. So I'm going to say that the function, let's create a variable. Let's say integer sum will be equal to num1 plus num2. Num2. Okay. Then I'm going to close my parentheses. So this you see over here is what is known as a function. Okay. So your parameters are there because they are the input values of your function. So assuming I want to use this function, in order to call a function, all you have to do is to bring the name of the function. The name of this function is what? Add numbers. So I'm going to call the name of the function add numbers. Then whatever parameter you declared when you were declaring the function, you realize that there are supposed to be two parameters here. So assuming I call the function and I don't supply the parameters, there will be an error. So it means that I have to supply my parameters. Now I want to add 4 and 2. So that means that when I return this function, the answer is going to be 6. So I don't have to come and say 4 plus 2 because everything is in this function, add number. So when I call the function add number and put in the argument, when you declare it over here, they are known as parameters. When you input the values, they are referred to as arguments. Now, when I put in the argument, it's going to return the number 6. That is how functions work.
Okay. So my other question is,
Mhm.
when you were creating the physical function,
Yep.
you used the parameter t. Did the person specify the parameter we should use, or you just
For
use any parameter?
for the
That's
putcar
why I asked whether you can just
for the putcar function,
use
if
any
you
parameter.
if you look at the functions carefully, you're going to realize that the input value of the function is what determines the kind of parameter you use. I wanted to add two integers, so I declared two parameters, int num1 and int num2. But for the putcar function, the putcar function's purpose is to print single characters. Make time, read on putcar, read on put, and read on printf. I'm going to share this notes with you guys, okay? Because I speak of what all the functions do. I mean the standard library functions. And I talk about puts, I talk about printf, I talk about putcar, and I talk about many others. So you have to make time and read before we meet again for our next class. I don't think that those ones are in this particular one. But I'm gonna share the link to this notes and many more on the WhatsApp page. All right. So when we are done, we don't have a lot of time right now. I'm just gonna be scrolling looking for it. But then I'm gonna share the link to the notes in the WhatsApp page. So if you look at the putcar function, you're gonna realize that it's a function that prints a single character. That is all it does. So that means that when you're going to supply the parameter, it has to definitely be a character. So that is how come when we're declaring a putchar function, we came and then the return type is an integer because of ASCII. Oh my. So we brought the name of the function putchar. Then we supply the parameter char c before we now came to write the code of what the putchar function was supposed to do. So the parameter of the putchar function is a character, and the character, this could have been any name. We could have said the data type is char, then we can name it character. But then when we are supplying the parameter, we are going to say underscore. So now let's call a function. Let's use a function. So in order to use it, we'll say putchar. What will we put in here? You have to put in the parameter. So in order to put in the parameter for the system to recognize that it's not an ASCII number, but an actual character, you put it in single quotes. So let's say you want to print the character small a. So we'll bring single quotes. And this is how we use our putchar function. That is why we brought this parameter character. I hope that makes sense to you. So I can use my putchar function again. I'll say putchar. I want to print another character, capital A, in single quotes. But if I say putchar and I bring A without single quotes, then this over here is going to be an error because the system is going to recognize it as a number 65 because of ASCII. But when I do this in single quotes, then the system understands that, okay, this is a character A. I hope that makes sense to you.
If it's possible, I'd like to add some questions.
Sure.
I have some questions that I wanted us to catch up, right?
Uh-huh.
So, looking at the whole task, right? So it means that the whole task was to create our functions and place them in the
Prototype, the main.h.
Meaning the functions, I think they wanted us to declare the return types for the functions
Uh-huh.
and put it inside the main.h. And I'm guessing because it's .h, that's why it's a live or it's a defined library form to see.
Is
I
it
wanted
you,
to ask them, can we include like regular files like in other languages?
when you say regular files, what do you mean?
So let's say for example, you see the not the extension we use for the file is .c, right?
Yes, .c.
But in this case, we're including main.h.
But that's a header file.
Okay, so I was just asking that, looking at how other languages can files and then work with those files, maybe some functions to declare inside those files and call those methods. Can I do that in C or in C? I have to make it more like a header file and then call that header file and then use this.
You're exactly right. In C, you cannot include other files. You have to include only header files. But there's actually a way by which you can include certain kinds of files. Those ones are referred to as macros. MACROS. That's where macros come in. So the macros give you some level of flexibility to be able to include certain files that may not necessarily be header files. But then the macros themselves are header files. And that is what I was explaining to you guys over here. You're going to see something in the project. When you open the main.h file, you saw some things over there, which is if not defined, if defined. You see this thing you see over here, they are referred to as macros. This thing you see over here. If and if not defined, define, then at the end you're going to see end if. So that is what is referred to as macros. And they give you some amount of flexibility to be able to include files that may not necessarily be header files. But then these themselves are header files. But they are like variables. If you know what variables are, variables contain values. So this main.h you see over here is like a placeholder. So there are things inside the main.h, and those things inside that main.h may not necessarily be things relating to prototypes. It can be anything. But then the moment you include the main.h macro over here, then the function can now go back into the main.h file and use those things that are within it. But we have not come to macros yet, so I don't want to go too far there.
And last question.
Sure.
One of the things that I found was right?
Mhm.
I realized that made a point that we're using like a Unix
Standard, yeah.
yeah, right? But in my head when you said it, I got a bit confused because, for example, I was thinking in that sense, it's more of like the C compiler is what is allowing us to use for Unix standard. Because as far as I'm concerned, Windows is based on Unix, right? So if I was much more like Unix, I would understand. But somebody who is working on the Windows in my head, I was like, I wanted to ask for like clarification. Like, is it this compiler that allows us to
So
the C or something? I don't know.
the C program itself is a Unix program. The Unix operating system was created, the C programming language was created based on Unix concepts or Unix principles. That is why if you look into your ALX first Hello World project, if you look at the requirements of the project, they were saying some interesting things you have to know. The learning objectives. Who invented C? There's a reason why they brought all these things. Who are Dennis Ritchie, Brian Kernighan, and Linus Torvalds? If you look at this name, Linus Torvalds, it should tell you something. Dennis Ritchie is a guy who invented the C programming language. Brian Kernighan and Linus Torvalds and all these guys came together. They are the grandfathers of the Unix operating system. And the C programming language was built, sorry, the Unix operating system was built based on C programming language. Or am I mixing it? Wait, the C programming language, that's correct, right? So it's like when you are working in C, you are dealing with Unix. So the C programming language itself is a Unix programming language. So whether you're working on Windows, whether you're working on a Mac or a Linux operating system, as long as you're writing in C, you're writing a Unix program. It's as simple as that.
So it means that that right
That write function.
if everything actually see that probably been compiled, you could use it. So it's like a default in C software.
Exactly. Exactly. It's like a default C function. It's a Linux low-level system function. That is how come we can use it to create our own putcar function because we are not allowed to use printf. But actually, if ALX was allowing us to use the standard libraries, many of the projects that we did, all you have to do is to just import a certain standard library and then use it. Import, for instance, let me show you something here. In which project is this? This is Hello World. So let's go to a project like, let's say, functions. We go into the functions project. If you look at some of the tags, they tell you that write a function that checks for lowercase character. Then they give you the prototype. Then look at this for your information. The standard library provides a similar function. It's lower. Then that should tell you that if not for the requirement of ALX, all you have to do in order to answer this task was to just um, include standard input output.h or whatever header file, and then you're going to do is lower. Then you bring the name of the um, file you're trying to compile. Very simple. So you just say it's lower, and then you bring what you want to check, whether it's a uppercase or lowercase or whatever character. But because they are saying you can't use the standard library, then you can't use this is lower function. If you come down, look at the next task. The standard library provides a similar function, is alpha, but they are saying you can't use it. So in the real life, you're not going to be doing what ALX is asking us to do. It's because it's the beginning. But in the real world, when I'm programming, I'm not now coming to write put car and then struggle and try and do all these things when I can just say it's alpha and I'll check whether it's an uppercase because that function has already been pre-written by the C programmer, those who created the C program. So you want to check if something is an alphabetic character, all you have to do is to say it's alpha, then bring the thing you're trying to check in quotation, single quote, and it will check it for you. But ALX now says that you can't use this as alpha function. So now you have to go and create a function that is able to check if something is an alphabetic character. And if you look at something like this, you're supposed to use you can use like an if else statement or a for loop to be able to answer this question. Very simple question. You guys should make time and watch some of my YouTube videos. I've explained a lot of things. All these things that I'm saying, I've taken my time to explain them. I know the videos on YouTube are long, but take your time and watch them. They are really going to help you because I've taken my time to break the concepts down. If you're able to watch them in our next session, I'm not going to struggle trying to go back, explain. But at least as we go on, if there's any question, you can always ask them and then we'll get better at what we do. For now, I think I'm going to bring today's lecture to an end. I know I put a lot of things together, but don't worry. It's the beginning lecture. We are trying to find our feet. The next time when we meet, we are still going to go over functions. We'll go over variables. We'll go over operators because we need to talk about logical operators. That is the logical or, the logical and then the not operator. You're going to be seeing these a lot as you program. We need to talk about them. And then we'll also talk about, we'll delve more into data types and format specifiers. Then we'll delve into control structures like if else statements. And we'll also go into while loops. We'll go into for loops. And we'll also go into nested loops. And maybe in like 2 or 3 sessions after here, we'll now go into pointers, arrays, and strings, which are derived data types. So if anyone has any question, you can just go ahead and ask. And if you need any help, you already have my number, so you can always reach out to me. Okay.
One more question is
Sure.
in relation to the metric.
Okay.
Is the main reason for them letting us use metrics or go to have an appreciation of like
Yeah, it makes sense.
All right. So if there's any other question, you can just go ahead and ask. Or else we're going to call today's lecture a day. We're going to call today a day, and then we're going to pick up on Friday. I know things might be looking very convoluted and confusing to you, but don't worry. I tried to crash everything today, but in the subsequent sections, I'll pick the project one after the other. We are going to understand their concepts and break them down. But make time, go to my YouTube channel and watch the video so that I don't have to struggle a lot when I come here. If you're able to take your time and watch it, I tell you, you don't even need me anymore because I've already done all the work over there. You really don't need me. I'm telling you. Make your time and watch. It's gonna help you. Okay.
Is it possible to get access to the evaluates?
Yes. Actually, everything you are seeing is in my GitHub. I've already
The eval-
yeah, the Evernote. I've already pushed. If you look into um my GitHub, you're going to see a repo called programming notes. For instance, when I go into my programming notes repo, you're gonna realize that a lot of people have forked this repo you see over here, and I have a lot of stars, which even gave me an achievement. If I go into C, so I have JavaScript, I have Python, I have Shell, version control, several, and I keep updating it. For instance, if you see, I have just updated last 2 days ago. I update them. I updated this one 9 hours ago. I update them very frequently. If I go into C programming, you're gonna see many of the concepts you are learning in C and many of the things I'm teaching you right now. I've already put them in my GitHub, and they are there free of charge. You can just go and fork and have your own version of it. And then, for instance, if I open let me open, let's say, arrays. You guys are dealing with arrays today. I've explained arrays, see, with code examples and everything. All of them are over here. If I open for loop, there's so much you can learn on for loop over here with code examples and everything. So just go into my GitHub and everything we are studying in ALX, I have already put it in my see compilation. These are the flags by ALX. Everything is over here. So just go into my GitHub, you have everything you need. Yeah. And if you look at functions, if you open functions, I talk a lot about functions. What are functions? Their name, what I explained today, everything is over here. The naming conventions, types of functions, user-defined functions, function parameters, function one parameter, function that takes see. It's just endless. And I have assignments that I solve in the GitHub. See, there's no end to it. Just make time and go and fork it. And then make sure when you enter this repo, just give me a star, man. It took me a lot of work to put this together. So just give me a star and then let me also be pushed for it more. All right. So guys, if you need any,
Okay,
okay,
Engineer. God bless you so much.
you're welcome. If you need any help, you already know where to find me. So we're gonna meet again on Friday. Okay.
What time are you?
Yeah, I want us to meet earlier so that we can finish earlier. Let's meet at either 6 or 7, depending on what you guys will say. I prefer we meet at 6, but some of you may not have closed work, so let's say 7, right?
Okay.
Yeah, 7 is not bad. Yeah.
Okay.
So let's meet on Friday at 7. And if you have any question, you can put it on my WhatsApp page. I'll definitely come and explain. Yeah.
Okay.
All
Thank
right.
you very much.
Okay. God bless you guys. We're gonna
Okay,
meet
sure.
again.
Thank you very much for your time.
All right. You're welcome, man. Bye.